So the first thing is how to import and export STL files into and out of CATIA. Now, there are some other software that are specialized for handling STL or mesh files, okay? And I guess I mentioned STL files, but just in case, if I haven't, let me just make sure. So STL file, as I said, STL is a mesh file, and the difference between a mesh file and a parametric file that you create in a CAD software is, if you can see here, so when you create a sphere, right, this is the sphere that you create in a CAD software. It is parametric because it is defined by a center and a radius, right? And it looks quite smooth. Of course, it's not perfectly smooth if you zoom in, but it is quite smooth, and it has every information about any point on it that you want based on a few parameters. Now, when you want to 3D print that part, or when you get some data out of a scanner, the typical format is a mesh file, and mesh here means instead of parametric design, what you have is a lot of points on the surface, on the exterior boundaries of the part, and then you connect these points by primitive shapes, mostly triangles, and create small patches. And then if you have enough of these points, then your representation of the parametric object will be a relatively good, it's not super smooth, but relatively good representation of the surface. We call this a mesh file. And the process of connecting all these points using triangles, we call it tessellation. Okay, so when you have a scanner, as I showed you in the RP Lab demo, basically the scanner only collects a bunch of points from the surface of the object. Then tessellation is basically carried out inside the scanner software. When you say render my scan, that's where tessellation happens, and all of these points are connected by small triangles, and you get a surface. Okay? Now, when you get the surface out of the scanner, many times this scan surface that you have is not a clean scan. There are some extra points, redundant points, and small details that are there, and if they are there, you cannot really create a solid object out of this scan. And sometimes there are holes in it. Sometimes there are some rough surface here. When you bring the STL, there are so many small details, and basically you have to make it smooth. Sometimes you have to sharpen some details. So you have to do a bunch of things on the STL first before you can create a surface and then a solid object out of it. And you might wonder, well, if the 3D printer also reads the STL file, can I directly, assuming that the STL is clean, which is not, but if I can get a clean STL out of the scanner, can I directly send it to the 3D printer? No. Because 3D printer, the STL of a 3D printer and the STL of a scanner are quite different. Okay, so this is just a basically thin surface with no thickness and nothing, no information about the interior of the part. So the 3D printer is not going to accept this directly from you. You have to convert it back into a solid object and then save the solid object as STL or the other formats for 3D printing. Those STLs and these STLs are not exactly the same. These are quite sparse. They don't have all the info. Those STLs do. So the STL from scanner and printer are not most of the time exactly the same. You cannot just get it from the scanner, send it to printer. Plus, as I said, most of the time the scanner does not give you a clean scan. So this is one thing that I wanted you to know. The other thing is there are, as I said, some specialized software for handling mesh files like STL, like Fusion 360 by basically, I guess it's Inventor Fusion 360, right? Let me check that. So new Fusion 360, okay? So this is the software by Autodesk, and this is, you can get a free trial or something. This is a relatively good one, and it can handle all sorts of different meshes. It has some capabilities, good capabilities. The other one is SolidWorks. They have added recently a new adds-in, which is called Scan to 3D, and that one has limitations, and limitation is the size of the STL file or the number of points that the STL file has. If the number of points that you import in SolidWorks is more than, let's say, 50,000-60,000 points for the scan, it is going to crash. While CATIA, I have done, for example, I showed you this head I made for myself. This guy was like 8-9 million points, and CATIA could well handle it. So I suggest, as long as you can have access to CATIA, use CATIA instead of other software. But if you don't, then you might go with Fusion 360. It can handle well better than SolidWorks. Of course, you cannot then create surfaces out of that or parts or something, but at least you can clean up the STL files and get a good file. So first, how do we import an STL? So if we go to CATIA, we go under Start, Shape, and then we go to Digitized Shape Editor. Okay, and this environment has a ton of tools. Okay, and most of the tools are on the right hand side or on the bottom. The top one is this guy here, and you have import and then you have export. So you click on the import, and here it is asking you to get an STL file. And let's see if I can get one STL file that I have, otherwise I'll make one. How? By just exporting a file as STL. But I want to see if I can give you an authentic, a real STL that I got from Scanner, instead of just making up something. Let's see. I had something. If I can find it, that would be awesome. Let's see. Okay, and here you can scale it up or down, or you can sample it. So if you don't want all of the points, you can sample it down at 50%. So you're going to basically throw away 50% of your data. So you can sample it to reduce the size of your STL file. Okay, you can choose the default units for the scan. Are they in millimeters or inches or what? So here you have some control over it before you bring it in. But once you're good with it, you don't want to change or anything anymore, you say apply. Let's see. I can get this guy in and okay that, and here we go. Look at that. So this is the scan of teeth of somebody, and these are using the dental scanners that some dentists use or some people use for sleep apnea devices. And as you can see, these scans are not super clean. Okay, many of them are quite messy. Some of them are hollow, they are not solid. Okay, they are not what we call watertight surfaces. They are basically unwatertight, they are open, right? So when you want to do something to this, so first you bring it in, good. Now there are other things that you need to do. you can click on mesh info and get some info about this mesh, and then you can go ahead and clean up your STL files. You can trim it. You can, if there are holes, you can close them. You can smoothen it out. You can transform it if you want. You can split it. You can do all sorts of things, right? Merge them, create extra mesh, and so on. Modify it locally, create curves out of it. I'll show you all of those. And then create, if you want, surface, and then convert it into a solid part, okay? So here I got this guy. The first thing is, some of these scans, they have some points that should not be there. Okay, they have some erroneous points or surfaces. So the first thing you do, you come to this toolbar and you click on this guy, which is like the red cross. It says Mesh Cleaner. And you first click on this and analyze. That's the first step. If there is anything here, long edges and small angles are okay. They are warnings, they are not errors. If there are non-manifold edges, non-manifold vertices, inconsistent orientations, and so on and so forth, you might be, not might be, you should be able to clean them and get rid of them. So you see here isolated triangles, right? So small basically surfaces out of the main body here, here, here. So if there is anything, you have to check that and say apply and okay, and let this guy clean your scan first. So this scan does not have too much of a problem. So that's the first thing you do. Then, as you can see, this scan has a bunch of data areas that you can get rid of, right? Or they are too rough. You don't want to print something like that. So what you want to do is now start to trim the mesh, smoothen it out, and then hopefully you can what? Fill this bottom surface, right? So let's say I want to make something like a crown or something for somebody. So what you would do is, if you come to the toolbar for trimming, which is this guy here, here you can trim. This is the one that I said, mesh info. So if you, oh no, that's not this one. Let me get the mesh info here, this guy. So if you choose the mesh, you see here, this guy has 110,000 points, so it's not too bad. Okay, it's not a huge mesh, and it has 219,000, 220,000 triangles connecting these points together, and you can see the dimension of it, right? 79 mil by 61 mil by 23 mil. That's the surface area of it in meters squared, and so on and so forth, right? So it is going to give you some general info, this guy. Now I want to click on this scissor which says remove, and this is really good for trimming. There are several ways that you can trim. You can pick a specific triangle. If it's too small, you can trap an area inside, I'll show you, a rectangle or polygon or SP-line, closed SP-line, and inside that area will be eliminated. You can use brush and brush over the area you want it to be gone and flood, which is quite fancy but not super useful. So here, let's say, let me show you brush. So I use brush and then I use my mouse, okay, and I brush over the area I want it gone, right? And I say okay, and there we go, it's gone, right? So I can use brush. That's one way to do it. The other way you can do it, as I said, is trap. It's a little more accurate. And you can trap something inside the rectangle or polygon. So you click on it and then you draw the boundaries of a polygon like this. And when you double click, the polygon is closed. Whatever is inside it is going to be done like that. Okay, so as I said, initially you can do some basic trimming and do a little bit of cleaning. If it's too messy of a scan, which most of the time is, I suggest you do some cleaning. Okay, as I said, this work needs patience. If you want some magic single button that will basically give you the final nice scan, which you can convert into a solid object, it does not exist. Okay, reverse manufacturing is actually a quite difficult thing to do. Okay, so you have to make sure you got some relatively okay scan before you can do anything further. So here you see I'm just eliminating a bunch of things, and now if you look at here, when you clean you always leave some stuff behind. I don't know if you can see it well or not, but here you can see this small stuff, and they can be quite dangerous. Okay, because later if you want to reverse manufacture and create surfaces out of these guys, CATIA will not like your mesh file and say your mesh file has isolated triangles. Okay, so first of all, I do not recommend using brush as much as possible, but even if you do, make sure that when you clean it up, look at this back area here. Okay, so here I have done a little bit more cleaning on that and trimmed a little bit more, and then I check it again, make sure that it doesn't have any isolated triangle left behind or anything. So now I got it into a little better shape, right? So here I have shown you how to basically clean it up and trim it. Then if you want, this is quite a rough mesh, right? Some areas they have very sharp corners, sharp edges. So I can click on this tool and allow this guy to be a little bit smoother. And when you change this coefficient, the amount of smoothness will change up. So here is not going to be immediate, like if you see here, it removed some of the small things, small details, but it's not going to make anything completely smooth, right? So you see, for example, all this ups and downs on the teeth, which could be really the teeth itself, could be the particles remaining, and also the gums, right? So this tool, this iron tool, is not gonna do a perfect smoothing, and sometimes you don't even not necessarily need it, right? You don't want a completely smooth tooth profile that is different than the person's, right? So you have to conserve the profiles, but sometimes there are some small details you can clean out further and iron out, but this is not your tool. I'll show you where the actual one is for creating further smooth surfaces. So you go to Start, to Shape, and then you go to Shape Sculptor. So if you come here, then there is this iron tool here, it says Brush Smooth. This one has the power to really smoothen out, and depending on what radius you want, the size of the affected area would change. So I would say 2 mil, and then how much do you want this guy to push in? Do you want it to do gentle smooth, or a little bit basically more aggressive smoothness? So here I do that, and let me just show you, if I apply that to some area, what is it that this guy can do. So let's say I want to smoothen out maybe this area. So look, hopefully you can see the effect, right? Look at that. Look at this area. This is one of those areas that are here. Look at that. Right? So you see here, look. So I made the person's gum very nice and smooth, correct? Because if you want to 3D print these guys or CNC machine them or anything, if you want to, which most of the time in dentistry you don't, but if you want to, these are not easy to create, okay? These are very rough surfaces, and creating these surfaces with any machine, even 3D printer, it is going to be quite difficult, okay? So the non-essential parts maybe you can smoothen out. So now hopefully you can see, and I'm not applying a big pressure and I'm not applying a large radius. So now if you look at the gums, they are far better, right? Or if there is something on a tooth, again here I just do a little bit on one of these teeth so that you can see it, maybe here. Okay, so I just made it a little bit smoother, or maybe here or here. So you want to make sure your part can be manufactured too, okay? And I got it in a lot better shape now. So compare that against the one that I initially brought in. You need something like this. Then you can go back again to Digitized Shape Editor, right? So now there are holes here, and filling holes is not always trivial, especially when it's not really a hole, it's an open surface. So here I'll show you this tool here right below cleaning surface. This one will fill holes, but again here this is quite different. So when you click on it, it shows you the boundary of the hole, and here that's this guy here shown with this X. If I click on it and say, hey, try to see if you can cover it up for me, and I do, and it did. Of course it's not perfect, but if you can see, right, it did its best to cover it up. Of course this is not perfect scan, this is not perfect closing, because as you can see here there is a gap, right? So this is good mostly when there are small holes, not something major like that, right? So you see, and this guy, of course you cannot just take it to a 3D printer and do something about it. And you might wonder, why couldn't it do a better job? I'll tell you. The reason is these boundaries. Look at them. You want to create a mesh surface that basically connects to all of these boundaries, and it's not possible. Okay, so it's not a clean, smooth boundary. It has a lot of ups and downs, and connecting all of this together with one surface, it's impossible. Okay, so it did its best, but clearly if you say here, mesh cleaner, let's see, okay, it doesn't have anything, but again there is a hole, and let me see if I clean on this again. Does it allow me to? Yes, you see it detected that area, there is a hole over there, so I feel that as well, right? So I got that, but again, this is clearly not something that you can fit a surface to, okay? It's impossible. So one of the things you want to do initially is, if you can trim this with a plane, okay, with a plane with surface boundaries, with smooth boundaries, I'm sorry, that can give you a little better, cleaner boundaries like this. This is horrible boundary. Okay, so that's where we have this guy in our lecture. can I split a mesh with something, right? Can I do that? That is an important thing. Can I split a mesh? So if you can draw a surface with the smooth boundaries and cut the mesh, that probably gives you a little better boundaries than just using brush tool, okay, or the scissor tool. So here, let me show you that one as well. Don't know if Control Z would undo the fill hole for me, but oh yeah, it did actually. So let me show you how you can use a plane or surface to trim this. So this is what I do. I go on this side plane, for example, and then I go to Shape Generative, Shape Design, and then create a sketch. So here I'm gonna use an SP-line and create basically a surface, and for the moment let's just focus on the few frontal teeth for the person. So I use SP-line here, and then I say, well, could you just focus on this area? Okay, something like that. Get out and then use the extrude and provide enough of width for the surface to completely split the mesh file into two parts, right? So I get this one, and now that I have that, I would go ahead back to Digitized Shape Editor, and I'll try to split it. So I go back to Digitized Shape Editor, and I click on Trim Split Tool, and then I say the element to be split is the mesh file, the cutting element is this guy, and then whichever part I want gone, I click on it and put the scissor on. So here, you see I clicked on it, and then the scissor appears on the side that I want gone. I apply that, right? So you see that part is gone. And let's see if I can also cut this part out. Okay, so if I say remove all, yeah, it did just one side of it. Okay, so because it actually was cut into three parts, not two, right? So if you remember, when I cut this, these guys are separate surfaces. So I had this part, the other part, and the front part. So if I wanted to cut both of these, I should have put the scissor on both sides, not just one. So here, I do it again. I want this to be cut. The cutting element is this one, and I want this part and this part to be gone, right? And there we go. And now that I don't need the surface, I can hide it. And look now, it is quite better. The boundaries are a little bit more reasonable, right? At least on the side. And then I can go ahead and trim it again with another curve to or another surface to get this guy gone. So maybe this time I go on this front plane. Let's see. Generative shape design, go to sketch for me. Oh, I guess I chose the wrong plane. So I need this one. And you see the scan is quite warped, right? It is basically tilted. That's why when we draw a surface, it is not going to give me a nice thing. So one of the other things that you can do before even you come here is you transform this, which means you rotate it or translate it and try to put it in a better orientation and position with respect to the coordinate frame. So if I go back to Digitized Shape Editor, right, and if you look at your lecture, So here in one of the slides, let me show you where the slide is for your own reference on how to transform it here. Okay, so this is how you can transform using this common toolbar. Let's see if I have that guy over here. I don't see that over here. Okay, let's first make sure it is not in this workbench. So restore position. Okay, I don't think it is here, but you can find it from other places. Maybe it's under this one. Yes. So what I want is really rotate this guy. So I click on it and say I want to rotate this, and then I can see from a front view or something. Or here actually it is the right view or left view. And rotate this a little bit, right? So it says about what axis, and here my axis is going to be y-axis, normal to the plane. And then I can, you see, here maybe I go with something like this, 3 degrees, and okay that, right? So now if I go back, actually there are 2 STL files now. There is the original one and there is this one. So what I would do, I hide the original one. I don't need that. So now this one is quite better. If you see, the tilt is mostly gone, right? So you see I could eliminate the tilt. And now, as I said, I can go on this surface and create another curve, right? Using which I can create a surface and cut again. So I don't know what this one do. We have to check. You see, it is gonna cut some of the front teeth. That's why you have to see it from the proper angle. Okay, so maybe this has to come down. You see, it is definitely gonna cut this, guys. So this is not an easy job. It needs a lot of trial before you can get something nice out of that. Okay, let's see what this one does. So I get out now and extrude this again long enough to cut the object. Now you see there are some rough boundaries that this one would eliminate. So let's do it. Go back again and use this tool and say I want to use for element of the cut is this one, element to split. Let's see if it allows me to choose the rotated version. It doesn't actually, it only allows me to do the original extrude. And so what I need to do is I hide the rotate and bring back this guy. So it is gonna actually cut this one for me. And so I want this portion to go. If there is extra portion, you also have to, like, these are not all the same. Okay, these are disjoint. So you need to know which one you are cutting, okay? So you see here, when I do that, it is going to get all of this, but not these small portions that are disjoint. Okay, so you need to put scissors on them. If I apply, you see there are some small things left, but you get the overall idea, right? And now the thing is, this one is not really rotated. Okay, so this one still has tilt a little bit, so I have to rotate this one. But if you can now look at the boundaries, it is significantly better than the original one. I can cut this boundary too, right? So you see, if you look now, most of the boundaries, it has far better boundaries than the original one. And as I said, I can do further cleaning, right? So let me do one more, if you don't mind. Go here, go back to here, sketch. Let's see if I can cut this back of the part a little bit. This is a little bit messy, this back of the part, and now extrude, but this time we are not gonna do a lot of extrude. Okay, so let's turn this side. Oh no, actually it's this one that should go. This one, just go enough forward to go in between the two sides of the gum. So I go a little bit forward until like that. I can only cut the portion I don't like, and do it again. So trim on the last one, that is my cutting element. Get rid of this for me. Excellent. Okay, so now as you can see, I have a lot better boundaries compared to what I had. It's much smoother. If you want, I can rotate this and do a lot of other things to it. Or if there is a hole now, hopefully if I say fill the hole, it can give me a little better thing. So we can try it. Say, could you fill that for me? Let's see. Okay. It's not horribly bad. Looks the boundaries are crisp. Don't have too much garbage data, although you have some, like here, as you can see, because we didn't cut all the way around the object. Some parts are left like that, and we really have to, as I said, be patient, do a nice job in cleaning, because many times the scans that you would get in real life are something like that. For complicated objects, it is not possible to get perfectly nice, clean scans. Okay, so doing scanning and reversing it is a hard job. So okay, so let's say we get something like that. As I said, instead of doing the general command here that will fill any hole it can find, we can create mesh locally. Okay, so let me show you that one as well. So okay, so what is generating mesh locally? So here in this mesh toolbar, no, this one, you can create some mesh locally by clicking on the three vertices of the triangle, and it will create for you. So you see here it has mesh creation, or this one, interactive triangle creation. So let me show you the triangle creation. I can click between 3 points. So I click on this guy, and then so I want a triangle to be formed between this point. Let's see if we can choose this point, and that point, and look now. If you can see, it gave me this triangle. If you don't like it, you don't need to accept it. You have to exactly know where you are clicking, right? But if you know specific points between them, you want to click a triangle, create a triangle like this, right? So you can create your own, right? So this one, maybe then the next one comes between this, right? Let me do one more here. For some reason I keep losing them. And maybe here, bad point. Okay, you have to see your points from 3D and make sure exactly where you're clicking, otherwise you are not going to get a nice thing. So I click here, I click here, and then I click there, right? So even look, although I thought I made the nice triangle, look at what I did actually, right? So you have to be careful about what you're doing. Okay, so you can create mesh, as I said, using triangles or locally. Now, if there are several chunks of mesh, you can merge them together, you can split them, and there are more tools that I don't want to get into all of that. One of the tools I wanted to show you is this guy here, which is moving points. So you can deform a mesh locally by moving a point. So you say, hey, I want to click on that point, and then I want to move that point, look, along one of the directions. So here, right, I want to move this guy along Y and Z direction. So I changed my Z and I changed my Y, right? So I make like a local cusp or something. Yeah, you see? So I can deform my mesh locally and move a point, and I can do it on several points. So this guy here is a tool of itself, and you exactly need to know where you're clicking, how much you're moving, or add a point somewhere to the mesh. Okay, so adding, removing, and creating triangles, they are really for pro and people who exactly know what they're doing. If it's your first time dealing with this software, I do not recommend messing up with the original mesh. You can smoothen it, you can trim it, you can transform it, sometimes even if needed split it, but adding to the mesh or moving the mesh points locally might create some weird features that are hard to modify later. Okay, so my recommendation is don't do it if you don't know what you're doing. The other one is creating curves. So now the question is, how do I create a solid object out of this mesh file? So there are two ways. One is, I'll show you, you're going to fit a surface, and it's not a single surface, it's a collection of so many small patches. Using this quick automatic surface reconstruction, I'll show you, you can do that and then use that surface to basically cut a cube into a solid object like this. That's one way that's my preference. The other way some people do, they cut the mesh file with so many parallel planes and they get a lot of curves. And then they try to use those curves for a multi-section. Okay, so they use those curves and they create a multi-section. So here you might say, if I cut this guy with a bunch of planes parallel to this YZ plane, I'm gonna get a bunch of curves, and if I apply a multi-section between all those curves, I can get a solid version of this. Yeah, it looks easy. It's not that easy, of course, okay? But I'll just show you. So this tool here is for creating mesh section curves, right? And if you come, you can see it over here, right? So this is planar section, and if you go here, so this is automatic from XYZ. This is you define your plane. So let's say I want to define my plane, and it says what is your element. I said this guy, and then here it chooses YZ plane and parallel to that. If you want like XY plane and parallel to that, you want to cut, it starts from the bottom and go to top, you can choose this, right? And you can say how many of these planes you want and with what steps. So let's say I want like 50 of these, or even if 50 is too much, you can bring it down, right? So many of them will not even cut the plane, so don't use them. So see it from a side view that you can decide better. So maybe in this case 20, even less, right? So just use enough planes to be able to cut the part. If they don't cut the part, don't do it. Right, so you see here plane 14 is not doing anything. So you just need 13 planes 1 millimeter apart, and apply that, and okay. Now you have all of these curves. As you can see in green, they are like contour plots basically. And the problem is, some of your planes, when they cut your mesh file, they do not give you one contour, they give you several contours, right? And some of these contours are open, some of them are closed. You see here, these are open contours, these are closed contours. And so now using all of this, which are now stored under all of this planar sections all the way from 1 to here, 33, these curves that you can see, these are not easy to modify, clean up, and then use for multi-section. Because if you remember, when we did multi-section, the multi-section itself was a hard thing when you only had two profiles, right? You needed to modify the closing points to avoid twist. You needed to provide guide curves if needed. You needed to basically use the coupling of ratio instead of tangency, and so on. Now assume that from one plane to the next, you are not connecting one profile to one more. You are connecting like 3 profiles on plane 1 to 5 profiles on plane 2. It's impossible, okay? Right? You can see it here. Let me show you again. So if you look at the top plane, what it is doing, it is cutting this teeth at several close profiles. Then when you go down, you have again several close profiles go down, and when you pass this point, now you have what? Some closed and some open profiles. And you have to repair them, and then you have to know which one to connect to which to get this guy in solid back. So I do not recommend using this method if your scan is complicated. Absolutely do not go with this method. This is good for simple scans, okay? For simple scans, this is way better. So what's the alternative? If we don't want to do this, how are we going to create a solid object out of this scan or any other scan? So my solution is I fit a surface to it and then use that surface to trim a solid part. Okay, so let me show you. Now, this is a little bit, it needs more time to do the cleaning, so I'm not going to work on this one. Okay, I get you a little better, nicer STL file that does not need a ton of additional work to get it into a closed thing, but I can show you how to use that guy over like a sphere or something nice, as I said. So how? So this is what I do. I go ahead and create something, convert it to STL. So I'm doing a little bit of cheating, okay? I'm creating the STL with CATIA, not with the scanner, but the concept is the same. I have done it, as you can see, I have done it in the past on my own face profile, okay? So it's not something that you cannot do, but your scan has to be a lot better than those teeth scans. Those teeth are literally the hardest scans I have ever dealt with. So here, as I said, I'm gonna make something, and so 6 units, 6, 8 point R, create the sphere, right? So let's say this is my solid object, and now I save it as an STL file. Okay, now one other thing you have to pay attention is the quality of the STL file, which means the number of edges and vertices that are used to approximate the surface. You have control over that. Okay, and how can you control it? So you can have, let me again show you a picture. So if we go STL file, fine versus coarse. Okay, that's the difference between these two. So this is your parametric model, this is a fine STL, this is a rough STL. So you have control in CATIA over which one of these or something like that you want, right? You want the fine conversion or a rough conversion. Of course, this one is going to be a bigger file, this is going to be a smaller file, but this is too rough of a representation of the surface. So I prefer to go with finer mesh as much as my computer memory and processor allows. So where can you control that? You go under Tools, Options, and then you go under Display, and then Performance. And here you have these two parameters, okay? By normal in CATIA, these numbers are 0.2 and 0.02 default, which gives you a relatively rough mesh, and you can see here. But if you want really the best quality, I would go with 0.01 and 0.01. These are the smallest numbers or the highest accuracy of the finest mesh file that you can get. So you okay that. Now I would save my file as STL and I call it sphere. Right, and save it as STL file. There we go. Now I go ahead and import it, pretending that it is coming from the scanner. So I go here and change, right? and apply and OK it. So this is, of course, a very nice STL file. And one thing you probably have noticed by far is the color. So the color of mesh files in CATIA is what? Brown, right? When you create a surface, what color is the surface? Yellow. And when you convert it into a solid model, what color is that? Gray, right? So just by looking at the color, gray versus yellow versus brown, you can tell whether it's a mesh, a surface, or a solid object. So this is right now a what? A mesh, and you can see it here. Now this mesh is nice. It doesn't have anything to repair. It doesn't have any hole, no non-smoothness, so it's perfect. So now I'll show you how to convert it into surface. So what we need is go to start shape, and then we go to quick surface reconstruction. And then we use this command here for automatic surface and say fit a surface to this. Now here we say how many small patches do I want, right? So the more the object has sharper edges and sudden transitions in surface, you need more details. This is too smooth. You don't need a ton of patches. Okay, and then how much is the deviation between the surface and the STL file, right? The smaller you take this number, the better CATIA tries to fit the surface, the closer it tries to fit the surface to this STL file, but of course it takes a lot more time. So here, maybe a tenth of a millimeter is good for me, and maybe 10,000 patches. And then you OK that, and it is going to fit the surface, and you see, done. Okay, now there is the surface below it. If you hide the STL file, right, that's your surface. And this is not one single surface. There are a ton of small surfaces. If I go shading with edges, you can see them. Okay, so it's not one surface again. It's a ton of small patches which fit the STL file. Now you might wonder, how close is this surface to actual STL? Are there deviations, and where are these deviations the most, and where is it that they are the least? And you can do surface analysis and deviation analysis. Say measure the deviation, reference is the STL, and to measure is the surface, right? Sorry, I chose the wrong thing. There we go. Oh, so the reference is the mesh file, and to measure with is the surface, and you say apply, and then it gives you this contour, okay, with this legend, which is the red points are the points with max deviation. So you see the max deviation between the surface and the STL file is about 0.04 mil, and the minimal is negative 0.09. The green points are good points, the points that you have minimal deviation. Okay, so this one can tell you where the fitting was good, where the fitting was not the best. Okay, the red points are the points that can have up to that much of deviation. Now, if that deviation is acceptable to you, fine. Otherwise, you go back and what? You change the number of patches and you change the amount of deviation. So if I say, no, I want 0.02 and I want maybe 20,000 or 30,000 points. Let's see if CATIA can give me a fast thing. By the way, you cannot just type any number when you set the max deviation. You cannot just type any number for surface detail. These two numbers are related. So if you type more than what CATIA can handle, it corrects it by itself. I typed in 30,000, it says no, you cannot go more than 24,000. And now if you look, this guy is significantly smaller meshes, right? Significantly smoother. And if I go here, and let me redo this so that you can see, and I hide some of these guys. So hide this and hide that and redo this. Don't think if I update it, it's gonna do something, but let's see. No. So Okay, reference is sphere, and then this one is the surface. Give me the result. And you can see now that 0.044 is now 0.017 in this, so it's reduced by almost like 2.5, 3 times, right? So you can get better fit. But again, it depends on how much deviation is allowed in your job. Okay, so you can hide this if you don't need it. You're gonna put the surface back. If you want to see the smooth surface, do the shading without edges. Okay, so this is what CATIA could fit to the mesh file, and now I can use this to create solid object. How? This is what you do. If you now go to mechanical design, part design, right, under this surface-based toolbar, remember there was one of your commands called close surface. So if you click on this and say close this for me and okay that, okay, now it has created a solid object for me. If I hide this, you can see it, right? This is your solid part, and you can see it under different forms, right? So that's one way. If it's a closed surface, right? If it is a closed surface, you can use this guy. Another alternative is you create a block that completely contains your object like this. So make sure it is the surface is completely inside the part, like that, and then use the split tool. So use this guy. It says what is your splitting element? I say the surface, and it says okay, do you want the interior of this block, the part of this block that is inside the surface, or you can click on these arrows. What you want, the part of this block that is outside the surface. I would say inside the surface, and I okay that. There we go. If I hide this, right, I get my solid object. Okay, so this is how you can get the original sphere back. Now, one last thing is, as I said, if your object, original object, is not smooth, okay, it has sharp edges, when you fit the surface, you have more deviations, right? So when I want to, let's just, instead of a sphere, let's just do a cube, and you can see the difference. When I have sharp edges, what can happen. So I save this 30, right? Some very simple object, and I save it as cube 1, right? Then I save it as STL. Good. Now I repeat this process for this object. So I bring the STL file in. Right? That is the cube. And then, since this is nice and clean, I go and fit a surface to it. Okay, and I use some good amount of, let's see, detail and everything. Let's see if it can. Okay, it says no, you cannot go to that much. That's fine. Go. Now look at this. Let me just hide this so that you can see. Look, this is what it could fit. You see? You see how bad it is? right? Yes, because you have so crisp of edges. Your edges are too crisp. Okay, when your edges are that crisp, it is really hard. Okay? It's not so easy to fit a surface to them. Your surface fit would fail. So now let me show you another thing. If instead of having those crisp edges, you have a little bit filleted edges, right? So I go back. So either your initial object had fillet edges, so when you scan them or you convert them, you have filleted edges, or if you bring them here, you could go ahead and use the iron tool and smoothen it out. So here, let's see if I can make some of those edges a little better with this tool before I fit a surface to them, right? So let's see if we can focus on one edge. Okay. So I use, oh, what happened? Yeah, that's the problem with made scans. When you apply something on them, you're gonna ruin them. Okay, because this is an artificial STL file. It's not real from a scanner. It doesn't have too many points. So when you apply the iron tool to it, it's gonna completely reshape the thing. While when we did it on that teeth profile, it didn't, because it had too many points. If you look at this one, let's go back and get the info about this. So how many vertices does this one have? Let's just get that. Look, how many points? 8. Okay, so all it has is 8 points. That one we brought in had 120,000 points. So here, when you move one of these points using the iron tool to somewhere else, it cannot keep its shape anymore. It's too simple of a part and too small of an STL, and you cannot afford to move one of these vertices to somewhere else. It's gonna collapse the whole shape, okay? Again, because I made this out of something very simple and I saved it myself, it's not an actual scan with so many thousand points. So we cannot easily move the points around. Keep that in mind. Now, instead of that, let me open this cube 1 and apply a fillet to the edges. Okay, so I select this face and I go to fillet. Then even if it's not 5, maybe 2 or 3. And I also choose this guy too. And probably the edges. So I remove sharp edges. Something like this. Right? And I save it. And then save it as STL. Now look, if I go ahead and import the STL, okay, if I look at the number of vertices, from 8 it jumped to 888. Okay, because now you have fillets, and if I try to fit a surface to it, okay, let's see if it can do a good job here. At least it should give me a lot better than the one it gave me last time for the cube with sharp edges. I'm just doing a ton of optimization in the background and trying to get, yes. So look at this one now, right? Look at that. How about this? You see? That's how nice of a part you can get. Then, as I said, you can go and cut something with it or close it and create a solid object. And once you have your solid object, here I'll compare them side by side with the original one, just for you to see the good thing about reverse manufacturing. Okay, so I hide this and I save this as cube 2. And I just bring both of them into some assembly so that you can see them side by side. So I bring in cube 1 and cube 2. And of course, cube 2 is much bigger of a file than cube 1, right? So if you go and look, here, your cube 1 was 102, while your cube 2 is what? 7,900 kilobytes. Of course, because you brought in STL, you fitted the surface with too many vertices, and then you created a solid object out of it, right? So that's the difference between original file and the reverse manufacture file. Okay, but here, now the reason this is slow is because of that performance thing. Okay, if you turn that performance off, put those numbers back to reasonable numbers, then it should act faster. When you change the display performance and make it small, it makes your computer really slow. Okay, so now hopefully you can see them side by side, right? Yeah. Okay. Could get something very, very similar or almost identical to the original part. But again, it needs a lot of practice. So hopefully I could show you some basics about reverse manufacturing and digitized shape editor. I'll see you in the next lecture. Thank you.